To solve a problem like this using the box method, everything revolves around knowing how many terms we're using. I am multiplying binomials, so I have 1, 2, 2 terms, and 1, 2, 2 terms. 2 times 2 terms. So, I'm going to build a box that is a 2 by 2 box. On the left, I'm going to put my first one. I have an x and a -3. Along the top, I'm going to do these two terms, a 4x and a -5. You fill in the box the same way you would fill in a multiplication table. And I'll make it a little bit bigger so that it's easier for people to see. You don't need to make a bigger one, but I'm going to make it bigger for you to see. So we're going to fill this in the exact same way you would fill out a multiplication table. So I'm going to go over here and down here. 4x times x is 4x squared. Filling in this box, 4x times -3 is -12x. X times -5 is -5x. And -3 times -5 is +15. Here's one of the best parts about the box method. When you use the box method, and this works even when you have very, very large problems to do, if you used the box method correctly, you organized it, your terms were in the right order to begin with, your like terms will line up in a diagonal every single time. This will look better and better and more useful the further we go into this multiplying trinomials and very large polynomials. So, 4x squared, there's nothing in the diagonal, so it's alone, 4x squared. The x's, -12 minus 5, -17x. The 15 does not have anything in the diagonal, so it's just a +15. And we're done. So to use the box method, you would have to draw the box. In this case, 2 terms, so a 2 by 2 box. You write each term left and top. It does not matter which one you put on top and which one you put on the side. It won't make a difference. Just don't mix them up and write 4x and x and then -5 and -3. Just make sure that you keep them together. This whole thing on the left, this whole thing on the top. You fill it out just like a multiplication table and your like terms will line up in a diagonal. Are there questions from this example? Yes? This is extremely similar to what is known as the lattice method of multiplication. Some of you may have learned that, especially if you had a program that did Singapore math, where you do lattice method of multiplication, which is a different way of multiplying. Instead of the usual line them up on top, carry this number, add them all at the end. It's a different method. Same result, but yes, very similar. Any other questions from this example before we practice this? Fantastic.